cumulative frequency from the past. Anything? Nothing? Well, I tell you what, let's start with, I'll just cover this up. So, you don't have to do this on yours, but let's just say I cover that up. So we have a frequency table. Now it says the local council has been monitoring the number of cars parked near a supermarket on an hourly basis. The results shown are below. So what this suggests, so you interpret that table for me. What do you think it says? Yeah, I think.
Never mind.
What does it suggest? Anything? You can say, interpret it any way you want. What can you read from just that table, that part of it?
3 people parked between 0 to 19. There were 3 cars parked between 0 to 19.
Monitoring the number of cars parked near a supermarket. Okay. So you think there are 3 cars parked between 0 and 19 hours? What? Wow. Let's just. Okay, we'll come back. What does that? What alarm bells would that ring in your head? Why? Why? Yeah, I would go with that. You know, imagine if you're looking at it, you say 3 cars have parked somewhere between 0 and 19 hours at the supermarket. That in itself, you're like, oh, well, maybe it's just 2 hours. That is 0 to 19 hours. But then you're saying there are 35 cars that parked between 60 and 79 hours. Well, that's the thing. So we've got to interpret this table correctly. So any other goes at interpreting?
There's 0 to 19 cars per hour. That was there for 3 hours. It can't be that because then it'll be 17 hours.
There was between 0 and 19 cars, but there was 3. Like there was 3 in that group of 0 to 19.
So what does that mean?
So like there could have been like.
It's a difficult one, isn't it, actually? The way it's set up, it's quite a difficult thing to interpret. Read the question. It says, the local council has been monitoring the number of cars parked near a supermarket on an hourly basis.
Oh, is this a day? It was 3 days and it's from this hour to this hour?
It could be. Let's say they just went every day, they just went, well, let's go and look for 1 hour. I think what they did was they started at 7 o'clock in the morning or something and then worked till 8. And then, yeah.
So like 8 o'clock is the hour between 0 to 19.
Not quite. Basically what they're saying is, each one of these hours, now there's no information about the hours, when it happened, or anything like that, whether it was on the same day or the same week. What they've done is they've done a survey. It might have been random hours during a month. But when they went and counted for that hour, in that hour, anywhere between 0 and 19 cars were parked 3 times. So it might have been Monday at 7 till 8, there were 18 cars. Then Wednesday at 4 till 5, there were 10 cars, and so on. And so between 0 and 19 cars only happened 3 times over their survey. Does that make sense?
Yeah.
So that means that 35 times in their survey there were between 60 and 79 cars in the car park. So what I would say first to help you understand is, how many times did these people go out? How many hours were looked at?
5.
Pardon? So how many hours did it take to do this survey?
5.
Why do you say 5?
Because there's 5.
So what does the 35 mean?
95.
Why 95? What have you done there?
I don't know the frequencies again.
Okay, so if you add all the frequencies, you get 95. So we've got to interpret it, which is they did 95 hours worth of counting. Yeah? They went out 95 times. Okay? Now that could have been all done in a week. Lots of people, different car park, well, near a supermarket, so it could have been in different areas. It could have been one person went out 95 different days. It could have been a mixture of the two, spread out over a month, or could have been spread out over a year. But basically, there were 95 lots of 1 hour counted. Okay. So, what would you say about the amount of cars that tend to park near this supermarket? If you had to make some kind of conclusion. Is it a busy supermarket area?
It can be.
Why would you say that?
No, I don't think so.
You don't, again, why would you say that? Well, we don't know, do we? We've been told there is a supermarket. We've been told cars parking near the supermarket. We might assume that the people parking near the supermarket are going to the supermarket. Doesn't necessarily mean that's true, but we've got to make some kind of assumption. Okay. But remember, the whole point of this topic is for you to interpret things, make conclusions with reasons. So, for me, I would say this is quite a busy car parking area, supermarket, purely because there were, on 35 different occasions, anywhere between 60 and 79 cars. Now you might say, but it depends how big the supermarket is and depends how big the car park is. I would say in Bermuda, that's a lot. You know, if we go to the one up near where I live, you're not going to fit 79 cars in the car park. But if I go to outside of London, where you've got these supermarkets, where a car park can fit 500 cars, and you know, that's not a lot. But let's go with Bermuda, let's assume. So I'm going to say, assuming a small supermarket, looks quite busy. Also, I've got 25, anywhere between 40 and 59 cars. So every time I pop to the supermarket, it's more likely that I'm going to have somewhere between 40 and 79 cars. Okay? What would you say about going over 79, so the 80 to 99, what happens?
It comes down a little more.
It comes down. What, if you just had to pluck a reason out of thin air, why would you suggest that might happen?
Because it's very busy.
So 80 to 99 would be really busy. Why doesn't it happen so often though?
Because people will go to other stores if it's so busy.
Yeah, I'd go with that. I'd say if you look at it, it's probably a saturation point. Once you've got past 79, there's probably not that many car parking spaces, so you probably just disappear, go somewhere else. Okay. Maybe you're right. Maybe it's only happening when the sales are. But you know, conclusion. Right. What we've got to do though is actually we're looking at turning this frequency data into cumulative frequency. So what they've done is they've already added that onto the table, right? And most of the time for you in a test, you've just got to figure out one of the values. So you don't have to do them all. Does anyone know how to find these values?
I do. You add the previous one. 3 for the 3 you already have.
So the first one's going to be 3
Then
because
you
it's
add 3 plus 15.
okay. So this would be 3 plus the 15.
And you add 25 plus 18.
So I'm just going to write it in full. This one, W, would be 3 plus 15, which is the 18, plus the 25, which would give me W. Okay? And it should be then that 43 add 35 makes 78, which it does. And then 78 plus 17 makes the 95. Does that make sense to everyone? So cumulative frequency just builds up. Now, just Out of interest then, let's see whether you already know. What does that 78 now mean? A specific vocabulary. Go on.
Oh, I don't know. But, well, it's like there's 78 cars that have been between.
Remember, it's not 78 cars.
78 times there was 0 to 79.
Okay, good. So the number changes. So this number 35 was how many times it was between 60 and 79. But when we do cumulative frequency, we're always going back to 0 and going up to 79. So I could say 78 times there were less than 79 cars. Well, I'll actually say less than 80. Less than 80 cars. Right? Does that make sense to you? So you're going all the way from 0 to 79. So that's the important difference with cumulative frequency compared to just frequency. So the numbers for cumulative frequency are to do with what's less than. And when we read the charts, that's important. Okay. How do you all know how to draw and label the cumulative frequency curve from this? No? Okay. Let's have a look then. So, no, we don't have to do anything like that. So basically what we're going to do, alright, we need, on the y-axis is not frequency, it's going to be cumulative frequency.
Oh, on the y-axis.
That's what we put. Okay. And on the x-axis will be parked cars per hour. So it does say in the question, label your diagram. Definitely label. Now, what we've got to do is use the numbers in the table. So frequency has to go up to 95. So using this diagram that we've been given, we've got to get it right. So I'm thinking hopefully they've been nice. 5, 10, 15, 20, 25, 30, 35, 40.
10.
No, that's not. So it must be 10, yeah? So it's going to be 10, 20, 30. Now in that case, each little square is going to be worth how much? 2. Good. Okay. Draw my axis there. Now what goes along the x-axis? Which numbers?
0 to 99.
Okay.
0 to 9.
Well, do you remember up here, I actually made a little mistake here. I said times when there was less than, and I wrote 79. But actually it's less than 80 because 79 is the next number less than 80. So actually what we need to do is plot the lower bounds for each one. So 0, 20, 40, 60, 80, so on. Does that make sense? Okay. So we don't worry about this, the 19, the 39, the 50, the 9s. We just try and do the other ones. So make it fit. So 0, what do we have to go up to? 100. Right, well, we do actually have to go up to the maximum as well. So we have to kind of go to 0, we've got 10, 20, 30, 40, 50, 60, 70, 90. They've given it, that one's nice. So 0 to 100. Why do I go up to 100? Because the highest possible value would be 99. So we have to include it in there. So, to draw our cumulative frequency curve, then we need to put our values in. So, how many times were there less than 0 cars? What? How can there be less than 0 cars?
Oh,
So we do start it, in this case, on 0, because in the table, 0 is the lowest value. Now, if that wasn't the case, we wouldn't have to. Like, we would choose the lowest possible value for the 0. Your cumulative frequency should always start at 0. It doesn't necessarily have to start on 0 for the x-axis. So then we say the next value is how many were less than 20. 3. So if you see from your table, 0 to 19 would actually say is less than 20.
Can you explain why you do it at 20 and not at 19?
Because
doesn't the next group include 20?
yes, so that's why it's less than 20, not 20.
so why did you mark it on 20?
Yeah, why would you mark it on 19?
Because with the cumulative frequency, the points, remember on the table I said it's how many were less than. Now I could say between 0 and 79, but what I'm doing, it's not always like this group. Sometimes we've got other groups with more than, less than symbols. Okay, so this is a specific situation, and we have to kind of understand that, well, 0 to 19 is basically less than 20, right? And 20 to 39 is therefore less than 40. Remember, we can't have a gap. So if I did 0 to 19 and then 20 to 39, I would be suggesting that there's a gap between the two. So what we do is, when you read cumulative frequency, it's all about less than the value. So when you read a point on the cumulative frequency, it's about less than. So I'm interpreting my table and saying, right, the ones that I am going to mark, okay, so it's less, that one is less than 20, got less than 40, less than 60, less than 80, okay. And then I do need, which is what we've got, is a 100. And how many are less than 100? All of them. All 95. Okay. So I can plot it at that top one. Is that, maybe it's not the best explanation, but with some other examples. And that's the thing, so you have to kind of go to that top end, and that point of 3 is the less than a certain amount. Okay. And then we're going to 40 here, and it's less than 40 will therefore be 18. Okay. Less than 60 we had to work out. What was W? Say it again. 23? 43. Put 43 up there. Less than 80? 78. And then we should have less than 100 at our 95. So we've plotted all our points. Then, what we then have is we should draw a smooth curve. You will lose marks if you join them with straight lines. So you'll practice your curve drawing.
How come,
Go on.
what is it? Okay, well, plot can like be 0, 9, 0, 10, 40, 60, 80.
Yeah.
But why would you put 0, 0, would it be 3? Like, I would 3.
Say it again. Which one do you want to discuss? So is that one all right?
But No, I'm sorry, every Friday. I'm confused all the time, but I just like.
So basically, what I'm saying is, this group here, which has got 3, a cumulative frequency, is actually the less than 20 group. So I put it on the 20. This group here, 18, is the less than 39, sorry, not less than 39, less than 40 group. Okay? So at 40, I would plot 18, 40, 18. This group is the less than 60 group, so 60 goes with 43. And this final 95 is the less than 100 group.
I still, how come the less than 10 group you put 0?
I didn't. I started at 0. So remember, less than 20, 20 I put at 3.
So
How many are less than 0? 0. Yeah. So your first one is always at that start point. So yeah, then we have to try and draw our smooth curve. So you'll be able to do this better than me. Mind you, that's not so bad so far. So we should get sort of an S shape. Now, one thing about a cumulative frequency curve, what will it never do and why? That wasn't what I'm thinking. We shouldn't draw it straight lines, like I said, but there's something else that it cannot do.
Oh, okay.
It'll never come down. It'll never drop. Why? Yours adding. You can't minus. You get that? So if your cumulative frequency curve ever comes down, you know you can't do that. So maybe you should add a note. These are our notes as well. Can't go down because it's always adding. So there's our cumulative frequency curve. All right, now this is kind of the next bit. How do you estimate the median from this? Yeah. To 50. Why to 50 though, is my question. Is it? Is 50 the middle? Okay. So don't forget that your maximum is not at 100. That's a common mistake, by the way, Hannah. So it's 95. Okay. So there are 95 numbers. Therefore, the median is, like you said, you go halfway, but you go halfway between 95 and 0, which is, what did we say? 47.5. So near enough 48. Go across. Now, again, my tip for you is draw it. Show that you know what you're doing. And also, it's amazing how many people do this. That's exaggerated, but it's got to go vertically. Be careful with your ruler. Just take a bit of care. Right? So find the point it goes to, join your line, and draw down. Now there are tolerances here, a bit of leeway, give or take, depending on what your curve's like, but not huge tolerances. You've got to keep it within a certain range. So if you don't show the line, there's a chance that you're more likely to get given the wrong answer if you're slightly too far away. If you can show that this is how I did it, this is how I found it, then you're more likely to get the mark. Okay, so that point there, this is then, okay, the median value. Right. And what do we think the median might be? So I've got 62. I've got about 63. So do you remember before when I said we have a group, you had to give the group as your median because we didn't really know what happened in between? Well, now, because of the line, because of the curve we've drawn, we can now estimate it. So this is an estimated median. All right? Okay. So I'll let you get on with the next one yourself. Okay, let's have a quick look at question 2, because I did say part C you can go through on your calculator. It's actually very easy not to, but let's work it through. It's about interpreting cumulative frequency. So, what are the values of M and N? Because you did 137 plus the 31 gives you 168. And then N, you'll have to do 194 plus 6 makes 200. Now, what we should have, and same with the other one, another check for you is this number should be the same as the number of students in the college. So if you didn't get that, okay, so the final one should be the same. Did we get the same up there? On this one, yeah, it's 95, and we had, well, we weren't told in that case, but this one we are. Okay, so we've got those two values. How many students are younger than 20? 137, yes. The first one younger than 20 is 19, and we have 137, 19 or less. Okay. Find the value in years of the lower quartile. Now, did you type it into your calculator? Yeah? Which is fine. Did anyone use a different method? No? Well, just to say then, do you remember we did our box and whisker plots, which we're going to do in conjunction? If your box and whisker plot falls on a range of like 0 to 200, right, the quartiles, well, the median would be found at 100, so the 100th person. That's a 200. Some of my writing is also not very good. My writing, your reading. If median would be the 100th, the lower quartile would be which student? The 50th student. So we've got 100th and 200th. And the upper quartile would be which student? The 150th. So actually I'm just looking for the lower quartile, the 50th student, and I can just look in my cumulative frequency. Well, there's only 3 students there, but I've got 75 there. So the 50th student must be in this group, 18. Okay? Does that make sense? But again, use your calculator if you feel, but you see how this question, you see how they would write a question where I would, if I fully understand, it takes me 2 seconds. If I don't really understand, but I can do it, like using my calculator, it might take me a minute or 2 to type it in. You still get the right answer, but where does the penalisation come from for taking longer? No marks. Yeah, your time. You run out of time at the end. Okay. If you can still get through anything, there's no penalisation. But they're saying that there is an optimum way of doing these questions, and if you have to be longer in all of them, then you'll get less marks. Okay. Make sense? Okay. Right. What we'll do is we'll move on from this one because it's another on graph paper draw. We'll save that one for another time. Let's have a look at the other sheet. Okay, so we've got this second sheet. What I would want to do is just show you. So we're going to go to one like this, question 2 on this sheet, because I want to introduce the box plot stuff. Right? So let's go through question 2. Right. So, again, got our information. Cumulative frequency shows the amount of time 200 students spend waiting for a train. Okay. Write down the median waiting time. Well, so importantly, what we've got to do is work out what the maximum is. So we've got to go across, we know it's 200, so just check, in case you weren't told it. So the median would we be at which value? 100, so we go from 100 across, it's a nice and exact one, this one, and then we read down. So I would say, probably not likely to be an awful lot of leeway on that one, so the answer would be 25. 25 minutes. Find the interquartile range. So this is what we looked at in terms of box and whisker plots. So the median is at 100. Where do you think, so what do we need, by the way, to do the interquartile range? We have to find the quartiles, the lower quartile and the upper quartile. So the lower quartile is halfway between, so it's at 50. So I'll go down there. And the upper quartile will be 150. Upper quartile, lower quartile. And by the way, just to show you, on here, look, they've taken it up to 250. Just to try and make you think, oh, should I be doing half of 250? But we've been told about the 200. So, interquartile range, we've got, what's that value? 16, after that. And we've got the upper quartile, which is 32. So the interquartile range is 32 minus 16 is 16. 2 marks for that. You lose one of them if you only write 32 to 16. Okay. Now, this is where we now go from converting from a cumulative frequency to a box and whisker plot. And this is where, to do this next type of graph, we have to be given this information, right? And the information we're being given is that the minimum is 0, the maximum is 45. So do you remember how we did our box and whisker plot before? So we put a line, however you want to use their thing. So I'm going to put a line at the minimum. My maximum is at 45, so I'm going to put a line there. Right. A line at the median. Okay, so that's 25. 25 there. Just keep it colour consistent. And then I'm going to do my upper and lower quartile at 32 and 16. So down. Okay. And then we draw our box and the whiskers. Yeah? Yes. You need to leave anything for us to bring down in 5 minutes. Then. Okay, so there's your box and whisker plot done. So we just transfer the information from our cumulative frequency to box and whisker plot. And that as far as I'm concerned, is some of the easiest 6 marks that you're ever likely to get anywhere in any test. So, why don't you have a go? Same idea, I think. That question there. So, have a go at question 4. Just to check, that box plot is worth 3 marks. How do you think you can ensure that you're going to get all 3 marks?
Doing the quartiles, the median.
Yeah, so quartiles, getting them right would be 1 mark. Getting the median right would be 1 mark.
And drawing the boxes.
And, well, getting the maximum and minimum actually and drawing the box, yeah, would be a mark. Okay, so you can see how you build up your 3 marks. So I would probably suggest, even if you probably didn't draw the box but you got the lines in, the box would be there anyway. So